Hey A&Pers, this is Dr. Jones checking in. This is A&P 2, Lecture Test 4, Video 7. And I have us on page 11, top of page 11. It starts with respiratory volumes. So now we're going to talk about all the formulas. So, let's not do black. I kind of like the green. We're going back to green. Okay, so VE is the respiratory minute volume, and this is the amount of volume of air that you move per minute, and we'll figure out how to calculate this. And the F, lowercase cursive f, is the respiratory rate, and that's the rate at which you breathe, so the number of breaths per minute. And then the tidal volume, which I mentioned, was VT, not TV. TV is television. This is tidal volume. So big V, subscript capital T. And that's the amount of air moved with each breath. So the formula is VE equals F times VT. So the respiratory minute volume equals the respiratory rate times the tidal volume. So if you increase either of these, you will increase the respiratory minute volume. If you decrease either the respiratory rate or the tidal volume, you will decrease the respiratory minute volume. Which makes sense. Okay, so now we're going to calculate. Yeah, that's not what we want. We're going to go back. And then we're going to up W. Up W. There we go. Okay. So we have the respiratory minute volume equals the respiratory rate times the tidal volume, like so. And while I generally don't ask you to actively math on the tests, you are absolutely responsible to understand the formulas and the relationships between these in the formula. So if our average respiratory minute volume is 12 breaths a minute, oh, I thought it was 16. 12, and here we have breaths per minute, and because y'all are college educated now, breath breathe. I don't see any of my students out there with misspelled protest signs. Spell it right. Okay, so this is 12 breaths per minute, and the respiratory. Okay, so we're calculating respiratory minute volume, and this is the respiratory rate, and we need the tidal volume, which is an average of 500 milliliters per breath. And as we discussed last time we did this, breath divided by breath is 1, and 1 times anything is itself, and so we're not concerned with that right now. And then the calculator told me once that 12 times 500 was 6,000. And we're left with milliliters in the numerator, excuse me, in minutes in the denominator, which simplifies to 6 liters per. Isn't this exactly what we got for cardiac output? 6 liters a minute. And now the respiratory minute volume is the exact same. It's 6 liters a minute at rest. That's interesting. Okay, so moving on. The anatomic dead space. So of the air you inhale, about 150 mils of it ends up being stuck in the anatomic dead space, which means it's in the respiratory system, but it has not yet reached an exchange surface. So the air in the anatomic dead space is the air in the tubes in the lungs, the trachea, the bronchi, the bronchioles. Also, I think anatomic dead space would be a great name for like a sitcom, like a morgue-based sitcom. There's jokes in there. I can't find them, but I know they're there. It sounds funny. Anatomic dead space. Okay. Like the, oh no, I don't remember the name of the show. The one with the zombie that works in the morgue. That one. So the alveolar ventilation is of the air you inhale what makes it to an exchange surface. So the alveolar ventilation is obviously much more important than the tidal volume. So let's figure out how to calculate the alveolar ventilation. We have the alveolar ventilation equals the respiratory rate, the number of breaths per minute, times tidal volume minus the anatomic dead space. So if you haven't algebraed yet, we've got please excuse my dear Aunt Sally. In the US, in England, they do it differently, of course. So for here, the P stands for parentheses. So we do the parentheses first. So we do the VT minus the VD. E is for exponents. There's no exponents here. Then multiplication, division, addition, and subtraction. Now, do you do the multiplication, division in order? You do the multiplication and then division. And then you do all the addition and subtraction as you find them in the problem, or do you go through and do all the addition and then go back and do all the subtraction? So it will often get you different answers, and those memes that you see where you can't do this math right, it's often about, do you do all the multiplication and then all the division and all the addition and then all the subtraction, or do you do the multiplication and division as you find them, going left to right in the formula? Okay, but let's whiteboard this and calculate average, or anatomic, not anatomic dead space. We want the alveolar ventilation. Okay, so our formula is VA equals F times VT minus VD. So the alveolar ventilation equals respiratory rate times the tidal volume minus the anatomic dead space. So please excuse my dear Aunt Sally. Please is first, parentheses are first. Oh, chicken's walking around outside. So the numbers we have here for respiratory rate is 12 breaths per minute times 500 milliliters per breath minus 150 milliliters per breath. Insert standard apology about handwriting plus handwriting with a mouse here. And then we're going to do the parentheses first. So the stuff that's not in the parentheses, we're just going to copy. We're just going to move it down. It's supposed to be a minute, not a meter. Okay, so the calculator told me once that 500 minus 150 is 350, although that looks right. 350. And the reason we can subtract here is we have the same things here. We've got milliliters per breath and milliliters per breath. If they weren't the same, it would be apples and oranges. We wouldn't be able to play this subtraction game. Okay, and then this one I did have to get from the calculator, 4,200 milliliters per minute which of course is 4.2 liters per minute. I was always off topic. I was always good at math, but when I arithmetic, which is this part, if I do it by hand, then I check it with calculator to make sure that I did it right. My mother, who maintains she's not good at math, will do the arithmetic on paper, pencil and paper. Well, no, she'll do it on she does it the other way. Like, she does it in her head and then checks it with a calculator. Like, she does all the arithmetic in her head, but doesn't think she has it right. It's funny. Okay. Yeah, that's this one. Okay, so this is the formula for the alveolar ventilation. It's the same except as the last one, except we're subtracting out the anatomic dead space because it doesn't do us any good. The air that's caught in the tubes is not contributing oxygen to our bloodstream, so it is useless. So we're subtracting it out. The alveolar ventilation is a more accurate number for us. Okay. Back to the note set. How does the air reaching the alveoli differ from the atmospheric air? It is lower in oxygen and higher in carbon dioxide because it mixes with the previous exhale that was also caught in the anatomic dead space. The respiratory minute volume can be increased by either, respiratory minute volume is the F, respiratory minute volume is the VE. So it can be increased by either increasing the respiratory rate or increasing the tidal volume. So increasing the breaths per minute or increasing the amount of air moved with each breath, which is the same thing we said about cardiac output. Same thing, except air, not blood. Now, under maximum stimulation, these can increase too. Respiratory rate can increase to 40 to 50 breaths per minute. And the tidal volume can increase to 4.8 liters per breath. We went from 500 milliliters per breath, which is half a liter, to 4.8 liters per breath. So taking a deep breath can make a huge difference in the amount of air that you move in and out of the lungs. So when you multiply that, you get maximum stimulation of VE, respiratory minute volume, of roughly 200 liters per minute, and our resting is 6 liters per minute. So huge change. Why is the alveolar rate more important? Alveolar ventilation rate more important than the respiratory minute volume? Because we subtract out the air in the anatomic dead space that isn't doing us any good. It determines the actual rate of oxygen delivered to the alveoli, which are the exchange surface. And then I have 2 bullets at the bottom of that page, and I have, if you increase the tidal volume, you increase the alveolar ventilation. The letters on those are so backwards. But also, if you increase the respiratory rate, you increase the alveolar ventilation. So those are the bullets on the bottom of page 11. Post it, post it. So top of page 12 looks like this for me. Did I start a timer? No. That's what my timer says. 15 minutes. Yep. Just push start. Just push start. Okay, well, we are going to cut this because this is kind of dense information, and that page was a lot of a page. So we're going to cut this video here to make this denser stuff a smaller chunk and easier to come back and review. So this has been A&P 2, lecture test 4, video checks notes 7, and we did just page 11, and we're going to cut it there. We could keep going, but the next stuff is a little bit different, and this is dense stuff, so I expect you to watch this more than once. So thank you as always for tuning in. The education must go on. Dr. J out. After I find my keyboard, and then push the buttons, and then it goes bye-bye.